My name is Robert Ray, President and General Manager of MaxiEnergy USA. I would like to take the time today to explain the MaxiEnergy Garbage Conversion to Electricity Facility. The purpose of the facility as a whole is to reduce the volume of municipal solid waste or garbage being disposed of in landfills. The volume reduction will exceed 90%, meaning if 1,000 tons enters the gates of the facility, more than 900 tons will either be converted to energy or recycled. The facility will be designed as a zero-discharge facility, meaning all wastewater generated will be reused on-site. We will also capture and reuse as much rainwater as physically possible within the site location and size. The facility is broken down into two parts: the municipal recycling facility and the power plant. In the development of waste to energy across the world, these two facilities are typically not located at the same location. The purpose of the municipal recycling facility is to receive the garbage, remove the recyclable and undesirable materials, segregate and compact recyclables for sale, and shred the garbage to make refuse-derived fuel for the power plant. The purpose of the power plant is to convert the refuse-derived fuel to electricity, control the power plant emissions within required limits, measure and record the power plant emissions. The design considerations of the municipal recycling facility are: beginning with the scales, which weigh all trucks in and out, empty and full. Radiation monitors actively scan the incoming loads for radioactive material. If the monitor goes off, the load is segregated and investigated. The facility will have stringent procedures to follow if this should occur. All incoming loads are charged a fee. Data is collected for later analysis by plant management, engineering, and regulators. The building itself is not some ordinary industrial structure. It has several unique features to customize it for garbage handling. It is very large, allowing the garbage trucks to enter into the building to dump their loads. All garbage handling is done indoors. The flooring is treated with a coating as ordinary concrete will wear over time. The floor is sloped for moisture drainage, collection, and reuse in the facility process. Ventilation is designed to maintain at a negative pressure, pulling air in, effectively containing any odors. The ventilation fans are provided with charcoal filtration. The charcoal will trap the odors. Noises are controlled at the source by providing sound insulating barriers to protect workers' hearing. Controlling noise this close to the source will ensure that the facility does not disturb the community. The garbage handling process will consist of the haulers will dump their loads on the floor while moving forward. This will spread the load out in a reasonable depth for inspection. Inspectors will check the load for hazardous materials such as paint, insecticides, flammables, etc. While these materials are not acceptable for receipt by the facility, they will undoubtedly be found. The facility will collect, segregate, package, and send out for proper disposal those materials. The inspectors will also be on the lookout for undesirable materials. These are materials which are not hazardous but are not compatible with the facility process. Equipment operators will move and stack the garbage in preparation for processing through the sorting line and feed the material to the sorting line. Garbage is processed by a series of conveyors and devices. The first such device is the trommel screen. The purpose of the trommel screen is to tear open any bags and to drop out any small non-combustible material. It will also aid in moisture removal. The sorting line consists of workers monitoring the garbage moving past them and removing the specific recyclable item assigned to them. They are on an elevated platform within an air-conditioned space. This room allows them to drop their designated materials into bins which are situated below. The recycled materials are collected into bins beneath the sorting line. These bins are emptied into larger bays. The material from the larger bays are fed into a baler for compaction and baling. The bales are stored until enough bales are collected for shipment. Loaders will load the bales onto trucks, and the trucks will be weighed out at the facility scales. In a traditional municipal recycling facility, the residual material would be loaded onto a truck for transport to a landfill or conversion facility. Instead, the residual material progresses onto the heater. The intention of this heater is to remove additional moisture content from the garbage. The heat source for the heater will either be waste heat or steam. The purpose of the shredder train is to convert the residual material from garbage to refuse-derived fuel. The garbage progresses to the coarse shredder. The coarse shredder's job is to simply take the remaining garbage in all of its shapes and sizes and reduce it to a uniform size for the fine shredder. The coarse shredded garbage then passes under a magnet which will remove any small ferrous metals that might have been missed on the sorting line. While the primary purpose of this magnet is the protection of the fine shredder, it will also produce a small stream of recyclable material which will be collected and sold. After leaving the magnet, the material passes through an air classifier which will remove additional, heavier, non-combustible materials. Again, the primary purpose of this device is the protection of the fine shredder. The fine shredder shreds the garbage one last time to the final size in preparation for conversion process. Conveyors move the refuse-derived fuel to storage bunkers. Material handlers are the last devices in the municipal recycling facility. They will feed the stored refuse-derived fuel to hoppers, which provide the fuel for the boilers. The power plant is pretty standard, with the only difference being the fuel is shredded garbage instead of oil, gas, or coal. The boiler consists of many different parts. The hoppers, which are fed from the material handlers, are feeding the metering bin. The metering bin simply provides a small reserve of fuel for the screw conveyors. Each boiler has 2 screw conveyors. The screw conveyors are driven by variable speed drives which take their commands from the boiler control system. This combination provides a very fine control of the fuel feed. The fuel is delivered by screw conveyors and progresses down a slope of moving grades. The air from the combustion air fan is provided beneath the moving grates, driving the combustible gases from the solid fuel, with the bulk of combustion occurring in the space above the grates. Ammonia is injected into the combustion zone as commanded by the control system. This is to control the emissions of nitrogen oxides, or NOx. Many diesel trucks do the exact same thing, only they use urea as the ammonia source. The boiler utilizes the heat generated by the combustion process to heat the feed water sufficiently to turn the water to steam in the steam drum. The steam then flows back through the hot gases before proceeding to the steam turbine generator, picking up additional energy. The control system is monitoring and controlling the process in the boiler to maintain steam flow and emissions. The control system controls the variable speed drives for fuel feed and combustion air. It is like your car, the computer is controlling the fuel feed and airflow to provide a clean and efficient combustion process. The control system here is doing the same thing. Emissions controls are based on readings from the SIM system. The control system will adjust the injection of urea or dry lime to control the appropriate emission. The steam turbine generator utilizes the steam coming from the boiler to create mechanical motion. The steam turbine is simply a glorified windmill, only it uses steam instead of wind to turn. The generator converts the mechanical motion of the steam turbine into electrical energy. While this electrical energy is simply a byproduct of the process, by selling the power to the local grid provider, sufficient revenue is generated to support the operations and maintenance cost of the facility, as well as sufficient to support repayment of the capital cost. The hot gases leaving the boiler pass through cyclone separators, which remove any large particulate carryover. The separators have 2 stages in series, each stage removing 95% of the particulate. Inside the exhaust gas duct, dry lime will be injected to control the sulfur oxides or SOx emissions. The bag house is the equivalent of a HEPA filter. It will capture any residual particulate remaining in the exhaust gas. The induced draft fan maintains the entire process at negative pressure to ensure no leakage. The stack is the plant exhaust pipe and also provides a sample location for the Facility Combustion Emissions Monitor, or SIMS. It is also equipped with sample locations for annual stack testing by a certified testing agency. This agency will provide initial startup certification for the equipment as well. Note that there is no visible emissions seen on this video. This video was taken on October 25, 2017 at the Commerce Refuse to Energy facility while operating at full load. The Combustion Emissions Monitor and Data Acquisition System draws a continuous sample of exhaust gas from the facility stack, measuring and recording the concentration of pollutants in the exhaust gas. In doing so, it provides feedback to the facility operator should pollutant concentration approach the specified limits. It also provides records of summary plant data and serves as a data historian for both internal and regulatory use. This equipment operates 24/7, 365, even when the plant is in maintenance, providing positive reference information to facility regulators. In summary, I would like to thank you for taking the time to watch this presentation. The goal of MaxiEnergy is to bring a viable, high-volume alternative for garbage disposal to the Philippines. In doing so, our intent is to be a good partner and neighbor. For your reference, our definition of being a good neighbor is we would not emit odors. This is taken care of by building design and operational procedures. Maintaining a litter-free environment. We take care of that by being sufficiently staffed and making cleanliness a priority. Controlling noise. Noise is controlled by equipment and building design. Zero discharge, allowing no uncontrolled runoff from the facility. Even should it rain, at least a percentage of the first flows will be collected and used in the facility process. Limiting power plant emissions. Emissions will be monitored 24 hours a day, 7 days a week, even when the power plant is not operating. This provides conclusive evidence that the plant is operating within established limits. We intend for the entire plant to be staffed by the local community. We will establish training programs to develop the required skills in-house. In the early years, MaxiEnergy may supplement with foreign expertise, but passing on knowledge and developing the local workforce will be a high priority. The facility will require the support and products of local industry such as machine shops, fabrication shops, motor rewind shops, chemical suppliers, safety equipment providers, foundries, office supplies, tools, heavy equipment, hazardous waste disposal services. The company will also participate in local nonprofit efforts.
Hello, my name is Ray Renison. I'm currently the Vice President for Operations, Training, and Safety for MaxiEnergy. I have over 35 years experience in the waste-to-energy field. I was among the first to be licensed to operate waste-to-energy plants throughout the United States. I've developed a training program which prepares all levels of plant personnel to meet the licensing requirements of the U.S. Environmental Protection Agency for waste-to-energy plants in the United States. I currently specialize in training of waste-to-energy supervisors and operators throughout the United States. I previously served for 30 years as the operations trainer for Los Angeles County Sanitation District, which operates both waste energy and landfill gas energy plants. Prior to that, I served as the chemical and nuclear reactor supervisor at South Texas Nuclear Power Project, Bay City, Texas. I spent 12 years serving in the United States Navy as a senior enlisted nuclear qualified supervisor, operating various types of nuclear reactors. I have various levels of qualification in the operation of waste energy plants, including being an OSHA safety instructor. I participated in the building of several power plants, including nuclear, waste energy, and landfill gas energy. I currently reside in Rancho Cucamonga, California.
Hi, I am Ferdinand Dakayanan, CEO of MaxiEnergy USA Incorporated. Our company specializes in garbage conversion to electricity. MaxiEnergy was formed in 2007 but was formally incorporated in 2015. The staff of the company are highly educated, well-trained professionals, highly experienced in the industry, and very much capable of constructing the most modern one-line process waste-to-energy facility anywhere in the world. We have over 100 years of collective experiences in the industry. We have a unique design, one-line process where you dump the garbage and get electricity at the end. This one-line process technology is an improvement to all waste-to-energy facilities in the world because normally sorting stations and power plants are in different locations. This technology was purposely designed for developing countries like the Philippines, and I hope you learned something and enjoyed watching the video presentation by our President and General Manager Robert Ray. For more information, please contact us at energy@maxienergyusa.com. Thank you.